For this problem, our job is to figure out what happens to the equation of y equals e to the x when you take that shape and reflect it over the line y equals 3. I'm going to start by drawing some axes and our standard e to the x graph. Here's e to the x. One thing to remember about e to the x is that it always passes through 0, 1 and has a horizontal asymptote of y equals 0. Now, here I'm going to draw the blue line y equals 3. Let's do this, blue, y equals 3. It's going to be hard to figure out what the equation just becomes at the drop of a hat. So what we're going to do is we're going to track the movement of this singular point, 0, 1, as well as where the horizontal asymptote y equals 0 is going to go. So one thing to point out is currently the distance from this line to this point is 2. We know this y value is 1, this horizontal line is 3. So we have this distance being 2. When I take this point and reflect it up across the line y equals 3, it's going to end up 2 units above the line. So actually, let's go ahead and give a crack at trying to draw this. Here's our upward sloping exponential. Now we're going to try and draw what it looks like if we were to reflect it. Okay, so we know this point, as I said before, is 0, 1. It is a distance of 2 units from y equals 3. But that means it's going to be 2 units above this line after it's reflected. So I'm going to say this is also 2 units, putting this coordinate here at 0, something. What is that something? We already know it's 1 unit above the x-axis. It's 2 more units here, 2 more units here, for a total of 5 units. So we're looking for a coordinate 0, 5. In fact, let's go ahead and eliminate some of these answer choices by taking 0 and seeing which of those functions give us 5 when I plugged it in. One thing to remember here is that e to the 0 is 1. Super crucial for evaluating these functions. So we have negative 0 is 0. E to the 0 is 1. 6 minus 1 is 5. That's possible. E to the 0 is 1. 5 minus 1 is 4. That's no good. Here we have e to the 0 is 1 plus 4 is 5, so this is possible. And then we have 6 minus e to the 0 is 1, so 6 minus 1 is also 5. I know I drew smiley faces, but it's kind of worrisome that we have 3 answers that all work, so we have our work cut out for us. We also need to track the horizontal asymptote. So the horizontal asymptote previously was here at y equals 0. Now it's going to move. We know this distance is 3, so it's going to wind up 3 units above the line of reflection up here at y equals 6. With that in mind, we should expect some sort of plus 6 on our equation. So with that in mind, it cannot be this answer choice, e to the x plus 4, to say nothing of the fact that e to the x without any sort of sign change here still looks like an upward sloping exponential. But now our pink curve here is a downward sloping exponential, so this could never have been right. So now we have to determine what is the key difference between this first answer and this second answer. One thing to remember is that let's draw a couple exponential graphs. I'm going to say a to the x, negative a to the x, and a to the negative x. So these graphs all look like this. I see a negative here and a negative here inside this expression, so I should expect some sort of flip across some horizontal lines so that it's going down like this motion, the motion that we see here. But I also have a negative in this with the x up here, so I should expect some sort of reflection over a vertical line, but we didn't have that. We only had a reflection across a horizontal line, so we shouldn't expect this as an answer because we only have the reflection across a horizontal line, not a reflection across a vertical line. So with that in mind, this has to be our answer.